Who needs slides? So, just to get this started, we've been doing this storage research for a long time. And how many of you guys saw Larry's talk this morning on looking at the sort of whole process, the notion of workflows and connections between? Nobody? Oh. All right, so this idea I think is really kind of fundamental, is that work doesn't happen in isolation. Work is actually most of the time a connection of something publishes something in storage and then something else accesses it. So so that's what really excited me. So Raja was involved in the original D3N work that we did, and so we kind of reset the stage for what we're doing, and then talk about how we want to kind of work together to sort of expand beyond that. So again, like imagine big data center. You have Nessie at the bottom, servicing block and object storage. So what we've been doing, the big data work, first of all, or the D3N work, we kind of move the Rados gateway that satisfies the A3 request away from that centralized storage and up into the cluster. So the high IOPS requests are happening near to the compute. And put into it a read cache was the first project. And that's all now upstream. It's in the Rados gateway code itself. And Orran, who's here, who did this for a PhD, she got tremendous performance results out of doing that. So now all requests are going through these object implementation that are near to where the compute actually is. Then we added a write back tier to it with a directory that tells you whether the data is sitting in the SSD tier or in the hard drive tier that's in that centralized storage thing. And all kinds of interesting results that were done on top of that, including coalescing small requests into larger requests before they actually go to that backend. So again, you're seeing sort of the coalesced requests end up having tremendously lower utilization of that backend storage, but there's really only one ultimate source for all the storage. The work on Greece, then, and this is where this really was inspired from, said, we had these, data analytics environments, things like Spark, and they actually have a schedule, and that schedule knows what data is going to be accessed when. It actually schedules the processes, but it actually indicates the data set. So if we could extract from the big data environment, from the client of the compute, what that schedule is going to be, then we can inform the caching from it. I mean, caching is essentially using normally historical information, guessing at what's going to be needed. Well, it's a lot easier to make a good guess at what's going to be needed if you know the future. And by extracting the schedule from the Spark environment, we actually knew the future. So informing the caching by that, you saw that particular workloads could get dramatic improvements. In this case, it's actually caching the critical path through the set of requests to accelerate it. So that sort of was a great result. And where all this work is going, and the last piece of it is the work that we've done very recently, which is we're actually doing, on top of that same object storage, virtual disks. So this has a dramatic reduction. We're using log structure techniques to, instead of writing things in place, we're aggregating to locally cache SSD and say large writes back. And all this work is either upstream or going upstream in the process. In this case, you're sort of seeing, we went from the traditional RPD, which has a 70% utilization of the disk at just 13,000 IOPS, to getting the disk to the back end only 10% utilized at 50,000 IOPS. So massive improvement in performance. And this is now actually out for review to go upstream. So we're moving to a world where everything is sitting on top of object storage. And once you have that, everything sitting on top of object storage, on top of immutable objects, then you can do some really neat things. Everything is talking from the compute to the back-end storage using, in this case, we've done everything on top of an S3 interface. We have the open storage network, which is these 1 petabyte data lakes distributed across the country. So now we can stand this up inside there, and we can have a world where we can be talking S3 to the object storage, we can be caching things geographically distributed, to wherever the requests are coming from, again, transferring using S3, talking to object storage that's outside of our own object storage, and even talking to our archival storage, data storage, deciding where to go. And this all becomes then a policy decision inside this intermediate form. So that's kind of where the storage research that we've been doing has been going. And one of the things when Larry started talking about, could we take the provenance information, could we, nothing ever happens just once. You sort of have data come in from, say, the marketplace or something else, or new AI element, and then that's going to have some predictable name. That's going to come into the object storage, and then, next time 1,000 things are going to access it. When we start predicting those things, start collecting a pattern of them, can we actually record not just the traces, but actually in the metadata of the objects, both the individual objects and the buckets, things that will give us a hint about what we should be doing with these objects. I think there's a richer focus of this on provenance for all kinds of other purposes from security, etc. But one of the questions is just for managing the caches. And now I'm going to hand it over to Raja, who actually can talk about what we do with it.
All right, so I'm Raja. I'm a faculty member at Tufts, and happy to be here as well. So Orran almost gave the entire talk to me, so thank you very much. That was great. I was going to let him keep going, but So just to set the stage once again, we're in this world now where objects live everywhere across the world in many data centers, and access to these objects are coming from also everywhere, right? There are lots of jobs, some that big data jobs like Spark, TensorFlow, or just custom programs. They're coming in to access these objects, right? So unlike the prior work, like derived, which Orran mentioned, which really relied on one execution graph, right? Knowing the execution model of a single job, and then knowing, if this job is going to access these objects and prefetching based on that. Now in this global world, we have lots and lots of jobs. We have lots of objects. And we really want to go prefetch across these jobs, know where we should be prefetching to, and knowing when to prefetch. So for example, over here, we have this new data set come in, and then there's this cleaning job that's launched. Perhaps launched in North America, maybe Washington, DC, right? And that generates a new object. And then soon after that, there's another team, the same organization that's running a bunch of machine learning jobs, using the clean object that was generated, perhaps some other objects, and then generating another data set. And finally, perhaps there are folks around the world who are then accessing the results of this machine learning job to get predictions or whatever else. The key thing here is there's both a sequence of patterns within these jobs and also across them. And so what we want to be able to do is predict across all of these things. Okay? And so I think that solving these things is going to involve several challenges. So we kind of listed these up here. So first, we need to keep track of the provenance, right? We need to keep track of which objects that we access, when, right? We might also want to keep track of some control flow information. Where are these objects accessed from, right? A key bit of intuition here that I that kind of came across when we were going over this little example is that these patterns across jobs likely represent some kind of underlying business process, right? So it might be that every day, a new pricing model comes in, or the new satellite images come in from the James Webb Telescope, right? There's a cleaning job that occurs on that data set. New data sets are generated, and then there are inference jobs or whatnot, right? So the underlying, what the data is remains the same, but the object names may change a bit to reflect new days or dates or whatever else. So we need to kind of templatize these object names. And then once we have these kind of templatized object names to kind of get rid of the variable portions of the names, we want to mine these patterns, mine patterns from them, so we can decide which objects can we access next, when, and where. And then finally, once we have these patterns, we need some way to key into them, right? When one object is accessed, which one should be prefetched in the future, where should we prefetch them? Right? So I think these are the key 4 challenges involved. In the next few slides, I'm going to walk through a couple of initial steps to addressing some of these challenges. All right. So the steps are, I think what we can do is in the storage layer, create like a logically centralized log consisting of the object accesses, timestamps, and some information about which regions or which regions of the world are accessing the objects. So you have the provenance, which is when the objects are being accessed, right? The sequence of the accesses, and we have control flow information, such as where did the access from, perhaps other stuff too, but we don't. We need to templatize this information so we can figure out where are the constant portions, what does this data represent? Is it satellite imagery data? Is it pricing data? Right? And then we need to tease out the variable portions, because those variable portions can affect any sort of mining we do in this data set to figure out what these business patterns are. Right? And just to reiterate, these business patterns, we expect them to repeat periodically. And then once we have this templatized data, what do we want to do? We want to mine them for these repeating business patterns so we know what the access patterns are. And then we want to store these patterns somewhere, key on within objects we accessed, and then prefetch data to the right regions. All right. So I think the easy part, the first part at least, is capturing this info. So how are we going to do this? Well, we hope we can scrape some of this data from log information that's being collected already from the OSDs or from application logs, right? We can propagate information about which regions are accessing these objects, right, along with HTTP headers of the storage requests, right? I just heard the CEF folks or the RGW folks, they were here yesterday, I think they disappeared. They were telling me how they've integrated some version of distributed tracing and open telemetry into RGW and CEF and upstream it. And so if we have that, then you can just use that and propagate all the information about regions and so on within the baggage fields of that exposes. Right? So you kind of get the ability to do this for free. And then, where we can store all the sequence of control flow information and provenance information, we can store it in some storage bucket somewhere so we have it. All right, so now what do we do? What do we have now? We have this log full of information about object accesses, and now we need to templatize it. Right? We need to figure out which portions of these object things will remain the same, and which portions are going to change, depending on the date or whatever else, like version numbers and so on. And so there's actually a lot of work in this area about figuring out templates for logs. So like a common approach is, for example, to use natural language processing to figure out conditional distributions about which portions of your log message will likely happen during another portion of the log message. And that way, portions that have low probabilities basically are identified as the variable portions. And then we can basically just replace those variable portions with some kind of single identifier. So that is not messing with the mining that's going to happen. Mining patterns, so there are a bunch of approaches, right? I think the most promising one might end up being subsequence mining, right? That we can try, but there are also a bunch of other approaches. Subsequence mining can be expensive, but the cool thing is we may have intuition about what patterns you expect to see. Some team will oh look, we have this data set comes in daily, and these 5 jobs get launched in response to it, right? We can encode that as a known pattern, and then mine the logs for when they occur and prefetch based on that as well. Right? So I think they can have kind of a combination of both of these approaches. And finally, we need to, once you have these patterns, you got to know when to prefetch. And I think that there are kind of like 2 basic techniques. One is we can assume the second we see an object, right, we're just going to prefetch all the items we see in the future, right? That we've observed to be accessed right afterwards. Right? So we can store the pattern, the future pattern, along with the object metadata. The second that object is accessed, we can just be okay, we'll get all the other objects. But of course, this object might be part of a larger pattern, and the future object accesses might depend on the previous accesses. Right? So in that case, you would need more of a global approach to solving this problem. Both these approaches require replacing the variable portions that we replaced, right, with identifiers with the actual elements, right? So one approach to deal with this is to basically find all the templates in our logs and cluster together the variable portions to figure out which dates or which values are close to each other, and replace those values back in our templates so we can actually prefetch them. All right, so next steps, right? Explore work in RGW, capture all this information, right? And I've walked through a bunch of initial algorithms and heuristics. We're trying to capture these patterns. We got to try the map, right? Got some choices. And then, get a little feedback from users and see about what's working and what's not working. That, we're back to Ron.
So, Russ, we try to find time, but I've been a little bit insane for some reason the last 2 weeks. But, time's up. But I guess the short is, this is just an exception of this, is that we have the potential of playing this for real. It's time for questions, or am I?
5 minutes for questions.
Okay, so just what I'm really excited about is nobody's doing this sort of longer term workflow analysis. I'm excited about extracting it, but I also think we can start deploying this for real, these new intermediate things that we've already got that sort of S3 interface to the zipper, record that information, even associate directly with the objects, and have people opt in to start using these new capabilities that we're developing so that we can sort of rapidly collect that information in real environment. And now I'll ask questions. Or just talk. Yeah.
I have 2 questions. One is, you mentioned about the probability being low and calculating being high. So what is the threshold that you, okay, what is the threshold for deciding, like what is the deciding factor threshold? And the second is, in the future, if the pattern changes, is your model adaptable for the future?
So those are great questions. I think they're all research questions. I think that the threshold might actually determine the false positive rate, right? So the question might be which items we prefetching incorrectly, right? Versus when are we not prefetching when we should, right? So that might be a tunable threshold that could be set. So that's the way I would phrase that. So what's the second question? Sorry. I would imagine this thing's being retrained periodically, right? So this is an asynchronous process. It's always running. It's almost like a control plane, right? So we are learning these patterns periodically, maybe every day, maybe every few days, and then we're updating the keys for prefetching future items. More questions?
Just a reminder, everyone should be filling out the Airtable form.
I think that the prefetching, we're trying to scope this down, but prefetching is just one of the first stage, right? You can imagine very simple packs. Something that's in a bucket is always small objects. So you saw the big advantage of this right coalescing, combining many small objects into a big object. You could start sort of making those decisions. Or if, let's say, objects written into a certain space are always, I never actually read, which I think is a very common pattern for, say, many of our papers, then it certainly you can imagine just sort of directly writing it out to the tape drive rather than intermediate things. So figuring out sort of the larger patterns, most of the work that I've always done, most of us have done, have been sort of just looking with no history at what's going on right now. This is trying to capture history to drive sort of the future demands.
And in fact, just to add to what Ron said, if you knew, for example, that we're looking for a pattern, it's like no writes after a bunch of reads, or all reads after a bunch of writes, or no reads after writes. If you know these patterns, then it's actually much easier to key on them, and then mine those patterns and kind of discovering unknown patterns. So I do think it might be a mix of these two things moving forward.
Okay.
Cool. Thank you so much.